Good afternoon. Welcome to PDC. I am thrilled to be here today. This is my first PDC, and I'm super excited to have the opportunity to interact with some of the smartest developers in the industry. I am very thrilled to get the chance to formally introduce to you today MSBuild, the new build engine for Visual Studio Whidbey and Longhorn. I don't know if you've tried this before, but today, building a Visual Studio project in an environment that does not have Visual Studio installed into it is not possible. I don't know if you've tried today, but being able to replicate the Visual Studio build process through some kind of a script, either a batch file or a make file, tends to be very difficult and very hard to get nearly 100% correct. Finally, if you've ever tried to actually augment the existing Visual Studio build process to really fit your individual enterprise needs, you might have found that that's also somewhat difficult today. I am convinced that MSBuild addresses those issues in the Whidbey timeframe. My name is Alex Kipman, and I'm a program manager in the Visual Studio core team. And I'm thrilled to have here with me today Rajeev Goel, who's a software design engineer in the Visual Studio core team. So let's get started. Quick overview of what we're going to be talking about today. We're going to take a quick glimpse at the key design goals of MSBuild and how MSBuild is attempting to solve the 3 issues I mentioned. We're then going to spend the bulk of the presentation taking an in-depth look at the full feature set of MSBuild. At the end, we're going to bring it all together in an end-to-end scenario to really show you how you can augment the MSBuild experience to fit your individual needs. So before we actually talk about the key design goals of MSBuild, I think it's important for us to understand why these issues are happening today. So the first issue I mentioned is the inability of being able to build a Visual Studio project file in an environment that does not have Visual Studio installed in it. This happens because today the actual build system is very much coupled within Visual Studio. If you then have tried to replicate that build process in your build lab, as I mentioned, that's a very hard thing to do. There's 2 reasons for that. The first reason is the actual file format today. I don't know how many people have actually looked at that file format. It's in XML, but it may as well have been written in Martian. Microsoft doesn't support that file format for you to actually change by hand, and unfortunately, in the past few versions, we've actually changed that file format, which from your perspective makes it very hard for you to be able to write tools on top of it. Now, because this file format is not documented, you have to kind of guess at what each one of these XML tags mean, and then you have to kind of infer what we are doing with them. So that's the first issue why it's so hard to replicate the build process in Visual Studio today. The next one is the actual build process itself. That build process today is very much a black box. There's really no way for you to figure out what Visual Studio is doing when you press F5. Turns out, we run through about 11 steps when you click F5, and we really give you today the ability to insert some pre-build steps and some post-build steps. But aside from that, we give you no mechanisms or recourse to actually change how that black box occurs. Now, that black box is doing a lot on your behalf, and it's actually a great project and build system today. But as a user, you have to trust it to work its magic to produce your final product. So let's take a look at how MSBuild is addressing these issues today. So the first one is the actual how MSBuild is written. We've written MSBuild completely from scratch, and we've separated it from Visual Studio. MSBuild has 0 dependencies on Visual Studio. It is written 100% in managed code, and it ships, as we mentioned, in the Whidbey timeframe as part of the .NET redistributable. That means it's part of the CLR. As soon as you have the CLR, MSBuild will be there. In the Longhorn timeframe, as you saw in the keynote this morning, as soon as Longhorn is installed, MSBuild will be there. The next issue we talked about is the actual file format. So MSBuild, in MSBuild, we've also taken a stab at completely rewriting the file format. We've rewritten it from scratch with the thought and design goals that it needs to be very easy for you to be able to read, write, and understand. This file format is going to be fully documented and backed up by a schema. It is fully supported by Microsoft, and we're guaranteeing you that you'll be supported in the next few versions of Visual Studio. What this means is that now, with MSBuild, not only Visual Studio will continue to be authoring these files on your behalf, but you can also have users or other tools being able to author these file formats in the exact same fashion with 100% parity with what Visual Studio is doing. These file formats will then feed into MSBuild, and MSBuild will produce the final product. Now, the key difference here, the key design goal difference from what we have today, is that in MSBuild, there is no black box. The entire build process and all of the steps that will make MSBuild transform your sources into final binary are fully expressed in the MSBuild project file. So just to recap, in sum, MSBuild is the new platform, the new build platform for Microsoft. It was 100% written from scratch in managed code with performance and scalability in mind, with extensibility in mind. But enough with the pretty pictures. Let me actually turn it over now to Rajeev, who will take you through some of the key concepts of MSBuild.
Thank you, Alex. I'm really excited to be here too, and it's fantastic to see so many people here as enthusiastic and as passionate about the build space as I am. Today, my goal is to walk you through some of the MSBuild file format concepts to give you enough understanding so that you can walk away from here and author your own MSBuild project files to execute whatever you need in your build scenarios. What we're going to show here today, I just want to mention, is based on very recent bits of Visual Studio and MSBuild. The DVDs you received or will receive soon do have a copy of MSBuild on them, and so you can play with it. However, you may notice some slight file format differences between the version of MSBuild that you have on your DVD and the version we're showing up here, which is based on, again, bits from just a couple of days ago. So I just wanted to make you aware of that. And then the other thing that will be different for you is that on your DVDs, unfortunately, you won't have as tight integration between MSBuild as Visual Studio as what we're showing up here. If you have any questions about what the differences are that you might experience, we'd be happy to answer them at the end. But just so you know, what we're showing here is not what's on your DVDs. But it is all very real. I don't want you to think that this is fake screenshots or anything like that. This is real. It's just based on more recent bits. Okay, so we're going to walk through the file format in a very demo-centric manner so that you can see it in action. What we have here is a directory full of source code and resources. What this is the source code for a popular yet very addictive game called Tetris. Now, if you're anything like me, you've wasted more than enough hours trying to play this game. So today we're going to make up for that by pursuing the more noble goal of actually building Tetris. Now, you'll notice we have some source code and some resources, but we don't have a project file yet. So Visual Studio knows nothing about this. No other IDE knows anything about this. Just a bunch of source code and resources. And we're going to build up the project file from scratch. So let's go ahead and pop open Notepad. Not because Notepad is the greatest XML editor in the world, but because Notepad is there. It's available for us on the OS by default, And so we'll just start out in Notepad just to demonstrate what can be done in a very simple editor. The root tag of any MSBuild project file is the project tag. And inside our project tag, we're going to create our first item. Now, items in a project represent the project manifest, as you'll soon see. They are the inputs into your project, so to speak. So an item needs two attributes on it, two required attributes. The first one is the type, and the second one is the include. And for those of you, again, who were present at the keynote this morning might recognize some of the syntax already. Now, the type is just a name that we need to give to this item. It is just something by which we can refer to it later on. The actual name that we pick is not important to MSBuild. We just need to pick something sensible so that later on in the project file we can refer to that item by that name, and MSBuild knows what we're talking about. Our first item, we're just going to say type equals compile. Again, compile is not something inherent to the MSBuild language. MSBuild engine knows nothing about compile. Compile just happens to be one of the arbitrary steps that happens to in a typical build process. Now, in the include, we're going to specify the file path for our item. In this case, we're just going to say mainform.cs, and this is one of the files that was on disk already, as Alex showed earlier. Okay, here's our first MSBuild project file, 3 lines long, authored in Notepad. Let's load this into Visual Studio. We've saved it out as tetris.csproj. If we load this into Visual Studio and open the Solution Explorer, you'll see that Solution Explorer has populated itself with your project manifest. That is, the list of items that are statically declared in your project file. In this case, we just have one. So Solution Explorer is showing us mainform.cs. Now, we can double-click on mainform.cs. It pops open in the Visual Studio Editor. We get full syntax coloring, full IntelliSense. If we wanted to, we could go to the object browser or the class view and get all those great navigation features. And again, with a 3-line project file that we authored in Notepad. So no longer do we need a really complicated project file to achieve some really powerful scenarios. Let's go back to Notepad now and add in the rest of the items for our Tetris application. There were a handful of CS files on disk, those C# code files. And let's go ahead and add the rest of those in. One way we could do this is by creating a separate item tag for each of those .cs files. The type would be compile on all of them, and we would just change the include path for each of those. And what that would do essentially is create an array of items of type compile. So items, you should think of them as lists. But instead of doing that, we're going to use a shorthand syntax and just say star.cs. MSBuild fully supports wildcards. So if we say star.cs, save this out, and reload the project into Visual Studio, what that dialog was that went by kind of quickly was just Visual Studio noticing that the project file had changed on disk outside of the IDE, so Visual Studio was just asking, do you want to reload the new project file? So we said, yes, we want to reload. And as you can see, Solution Explorer has populated with all of the .cs files from disk. Again, you can double-click, get the full editor experience, all of the great Visual Studio features. Again, with a very simple project file. Before we proceed to actually building this application, I want to do one more demonstration of wildcards to really show their power. And what I want to show you is how to use a recursive wildcard. What we have on disk, inside that Tetris directory, we have a subdirectory called AI. Inside that AI subdirectory, there are 4,248 .cs files. It's not real code. It's just junk. But they are .cs files with some C# code in them. And if I wanted to include all of those into my project, all I have to do is say AI whack star whack star.cs, and that takes every .cs file from the AI subdirectory all the way down recursively, and includes them into my project. So let's see what happens if we reload this one now into Visual Studio. It'll take a few seconds. There really are 4,248 files there. So it just takes a few seconds. And what you'll see now is that in Solution Explorer, you can navigate to any one of those files. And again, you could open them in the editor, get IntelliSense, and it's a really powerful feature if you've got a bunch of source code already on disk, but you don't have the project files associated with them yet. So a really easy way to import all of those into Visual Studio. Okay, let's get rid of that line. That code is not really part of Tetris. I just wanted to demo recursive wildcards. And let's reload this again one more time into Visual Studio and see what happens when we ask Visual Studio to build this project. Well, we got an error. Well, don't worry, this error is expected. The demo hasn't gone horribly awry, although that may happen later if my luck continues to go the way it has been. What this error is telling us is that there's no build target in the project file. The reason for this error is that Visual Studio is telling us it doesn't know how to build this project file. And the reason it doesn't know how to build this project file is that black box that Alex talked about earlier, that black box that used to be in Visual Studio so that it knew inherently how to build any project file, that black box is gone. Now, in order to build any project, the build process must be declared in the project file. Very similar to a makefile, right? And since we haven't declared a build process yet, all we have are a handful of items. There's really no build that can occur yet. So let's fix that problem by going back into the project file and adding some targets and tasks. Now, at this point, I'm sure Alex is getting a little bit tired of typing in Notepad. So we're going to go ahead and open that same project file in the Visual Studio XML editor. Again, no big deal here. We just want to have a slightly better XML editing experience. It's the same project file we had just typed in Notepad. Let's go ahead and add our first target then. And a target has a name, and the name, again, is an arbitrary name. We can pick whatever we want, but of course we want to pick sensible names. So we'll call our first target the build target. Inside the target, we want to call tasks to execute the actual build operations for our build process. And the first task we want to call is the CSC task. CSC is the C# compiler, and because we have a bunch of C# code, that is in fact what we want to do. We'll go into a little bit more detail on what exactly a task is, but for now just understand that they are the steps in the build process. We need to pass some data into the CSC task, the most important of which is the set of source files to compile. So we're going to say sources equals @compile. @compile is our syntax for referring to an item list that has been previously defined. So this is where the item type comes into play. We had specified our item type equals compile, and so we refer to that item list as @compile. So we're going to hand in all of those source files into the CSC task so that it can compile them. There are a couple other parameters we need to pass into CSC, the first of which is the output assembly. We need to tell it the path and the name of the assembly that we want it to produce. So we say output assembly equals bin/debug/tetris.exe. And the last thing we need to say is target type equals WinExe. And that's because Tetris is in fact a Windows application. Now let's reload this into Visual Studio and see if that fixes that error that we were hitting earlier. Divert your eyes, please, for a moment. Yes. Okay. So we reload the project into Visual Studio, and we hit build again, and now we no longer get that error. Now Visual Studio knows what to do with this project file because we've declared our targets. It called the build target. Within that, it called the CSC task, and the CSC task was kind enough to emit for us the exact underlying command line tool that it called to perform the compile. Now, again, csc.exe is the C# compiler, and it ships with the .NET redist and is in every Longhorn box by default. So we're seeing the exact command line that was executed under the scenes. This is something you've never seen before in Visual Studio .NET 2002 and 2003. It never gave you the exact command lines that it was actually executing. And the reason for that is that because of that black box, Visual Studio didn't really even know what the exact command line was, because all of that build process was hard-coded and in process. It wasn't really calling command line tools or tasks or any sort of extensibility mechanism. So now we have a much more auditable build process here. Beautiful. So we've built Tetris. Let's go to the command prompt now. And so far we've showed Visual Studio. Let's see what this looks like when building with MSBuild. So we have a command line tool called msbuild.exe. And if we run MSBuild, as you saw several times in this morning's keynote, it will run the build steps for the project we just created. And now, this is really important. It's doing the exact same thing that was being done inside Visual Studio. And the reason for that is, in fact, that Visual Studio is just calling MSBuild to do its build process. Again, I want to emphasize this, it no longer inherently knows how to build anything. It's just calling MSBuild. And so, because it's the same code path, you're guaranteed to get the same parity between your command line builds and your Visual Studio builds. And once again, MSBuild has no Visual Studio dependencies, and it does ship with every Longhorn box. So you can build a Visual Studio project now without actually having Visual Studio installed. I'll take questions at the end. Thank you. Okay. Now that we've built this, let's really quickly just try to run it. It produced an assembly in bin/debug directory, so let's run it and see what happens. We get this error. We'll fix this a little later, but just for now, this is just because we've compiled the .cs files, but we haven't compiled the resources in. The resources contain the bitmaps and the icons and the sounds and so forth for Tetris, and because they aren't there yet, we're getting this message box, which is being produced by the app itself. So let's OK out of that. And at this point, I'd like to briefly explain what a task actually is. You saw that we were calling the CSC task in our build process. But what is that task really? It's important to understand that that task is not an inherent part of the MSBuild language. It is a plugin. This is the main point of our extensibility model. This is how you plug in your own build steps into your build process. Now, MSBuild ships with a fairly good library of tasks that accomplish most of what you would want to do in your build process. But inevitably, there's going to be something in there, something that you want to do in your build process that is not covered by a task that we ship. And so I want to emphasize how easy it is for you to write your own task and plug it into the build process. What we're showing up here is a very simplified version of what that CSC task actually looks like. All it is a class that derives from the task base class, which is a base class that is provided in the MSBuild class libraries. And inside this class, we're going to create a .NET property, a public .NET property, for each of the input parameters into the task. So we've got a public .NET property for our sources, and a public .NET property for output assembly, and so on and so forth. I've only shown two here. The real CSC task, of course, has like 35 or 40 input parameters for all the different switches, warning level and optimizations and all of those things. I just wanted to keep this simple for demonstration purposes. And then after you've declared your .NET properties so that you can pass input parameters into the task through the XML, the last thing you need to do is implement the execute method. Now, this particular execute method, all it's doing is launching the csc.exe command line process and passing in a bunch of switches to it. However, the real power of tasks comes in when you want to do something that you don't already have a command line tool for. Tasks can do anything that you can do in code. You could pop up UI, you could call, crypto API, you could do literally anything here. And the other really powerful aspect of this is that you can debug into it. So as you're going through your build process, you could just set a breakpoint inside your execute method and start stepping into your build process to debug into maybe something's going wrong in your build process and you want to diagnose it. So we're not going to demo debugging here, but I just wanted to show an example of what a task might look like. So in this case, again, we're launching csc.exe. We're waiting for it to exit. We log an event that tells the user what the exact command line was that we executed, and then we return true or false depending on whether it succeeded or failed. Beautiful. Let's go back to our project file now and kick it up a notch. How can we make this project file a little bit better? Well, one of the ways is by using properties instead of hard coding some of the data inside the place where we're calling the CSC task. So, for example, we'll create a property called assembly name and set the value of that property to Tetris. And then down below, instead of hard coding Tetris, we'll just say $assembly name. $sign being the syntax you use to refer to a property. Similarly, we'll create another property called output path, set its value to bin/debug, and refer to the output path property down below, again using the $sign syntax. Now what this does is it just makes that piece of XML down below a little more reusable. Let's go ahead and build this again from the command line just to show that it is in fact doing the exact same thing that it was before. And because of the beautiful logging, because you're seeing the exact command line that was run under the scenes, you can verify that it is in fact doing the exact same thing. Okay, let's go back to our project file one more time. Actually, not one more time. We're going to do this several more times. And let's see what configurations look like inside a project file. Now, if you've played with Visual Studio, you know that when you create a new project in Visual Studio, by default, it gives you two configurations, the debug configuration and the release configuration. Well, configurations really are just a bag of properties, right? For example, your debug configuration sets warning level to a certain value, it sets optimizations to a certain value, and your release configuration sets different values for those properties. So all a configuration really is a different set of properties for your build process. Well, configuration may not be the only thing that you want to tweak your build process on. You may want to have different properties for different platforms, different processors, different architectures, different anything. So MSBuild inherently doesn't have a concept of a configuration, but it emulates the same concept by using a condition. So what we're going to do here is we're going to take those two properties and put a property group above them, a parent property group. And on that parent property group, sorry, not the two properties, just the one property for now, my mistake. And on that parent property group, we're going to add a condition. The condition is that the configuration is equal to debug. So what that says is when my configuration is debug, set my output path to bin/debug. Let's go ahead and put one more property inside that property group. Property group can contain an arbitrary number of properties. And we'll create a new property here called generate PDBs and set the value of that to true. Great. So again, what this is saying is that for my debug configuration, here are the two values of the properties that I want to use in my build process. Now, configurations are really only interesting if you have more than one, right? So we'll go ahead and copy-paste that piece of XML and create a new configuration, an arbitrary configuration that we can name whatever we want. In this case, let's just call this PDC_config. I'll just create a new configuration. Inside here, let's just set the two values of my properties to something different, just so that we can see how the two configurations behave. Okay, that's great. The one other thing before we try and actually load this into Visual Studio is that we've created this new property called generate PDBs, but a property isn't really useful unless you're consuming it. So inside the CSC task, we're going to pass in a parameter called emit debug information, and we're going to pass in the value of the generate PDBs property. Usually you would name your properties similar to the parameters that they're being passed into, but I wanted to avoid confusion here, so we named the properties differently. Great, let's reload this into Visual Studio and see what happens. If we go to the project properties for our Tetris project now, and we go to the configuration properties, the drop-down up top automatically populates with the configurations that it picked up from the project file that we authored by hand. This is just one example of the really great integration that we have between MSBuild and Visual Studio. If we were to select any one of these configurations as our active configuration, you would see that in the property pages, it is in fact showing you the values for all the properties that are part of that configuration. I know the font on the property pages is really small. I apologize for that. That was one of the things we couldn't figure out how to crank up the font size. But for those of you who can see it, like basically people in the front row, and that's about it, it does so that for the PDC config configuration, the output path is set to bin/PDC. Great. Let's cancel out of the property pages. And now that we're actually producing debug information, that is the PDB file, for our debug configuration, we can actually debug this project now in Visual Studio by hitting F11. F11 is the shortcut key for stepping into a method. So if we hit F11, we're debugging into our project and stepping through the code. And if we hit F5 at this point, we'll again get that same error that we were getting earlier because we haven't built the resources into our project file yet. I promise we'll fix that error. Don't fret. But before we do, one more demo from the command line. So if we go back to the command line now, we also need a way to select our configuration here. We don't have the beautiful Visual Studio UI, so we need some other mechanism. Now, if you remember back to the project file, when we were referring to configuration, Alex typed in $configuration. The reason he did that is because configuration is just another property. And we need to set its value just like we would set any other property's value. Now, one way we could do that is in the project file itself, we could add a property at the top of our project file that said, property configuration equals and then whatever configuration. But hard-coding the configuration into the project file makes it not as useful as being able to set it outside the project file. So one thing we could do is just set an environment variable called configuration. All environment variables are imported into the MSBuild project file as properties, so we can refer to them as such using the $ syntax. And so we've set an environment variable called configuration equals debug here. And if we run MSBuild again, we can see that it is in fact using the properties that were associated with that debug configuration. There's one more really cool way to set properties from the command line, and that is using the /p switch on the msbuild.exe command line. And properties specified here have the highest precedence. So they override environment variables, they override properties that were in the project file, they win over everything. So here we could say /p : configuration equals PDC _ config, configuration equals. Okay. And what we'll see now is that we will build with the set of properties for the PDC configuration. And sure enough, we have turned debug information off, and we are building to the bin/PDC directory. Great. Okay, finally, let's fix that problem with the resources that we keep hitting. What we need to do is include all of those .resx files that were on disk into our project. So we're going to create a new item list. We're going to give it a different name, because this is a different conceptual set of items here. We're going to say type equals embedded resource, include equals star.resx. Now, what we want to do with these resx files is pass them into the resgen task. Again, the resgen task just is equivalent in functionality to the resgen.exe command line tool that many of you have probably played with. So just before calling our compile, we call resgen. Again, we pass in sources equals, and then the item list. again, using our item list syntax, @embedded resource. Now, what ResGen is going to do is it's going to take those .resx files and build them into a binary form of the resource. And that binary form is going to be put into a file with a .resources extension. And what we want to do with those .resources files is send them into the compiler so that the compiler can embed them into the final assembly. So how do we do that? Well, fortunately, the CSC task has a parameter on it called resources. And so we want to pass in the resulting built resources into that parameter. But we don't have an item list already declared that represents the built set of resources. And the reason I don't want to declare a static item list like that is because the built resources aren't really part of my project manifest. They aren't the raw inputs into my build process. They are, in fact, a byproduct of some other build step, right? So the way you're going to do this is by referring to a virtual item list. And when I say a virtual item list, I just mean an item list that is created during the build process but is not statically declared in the project file. Again, we can give our item list whatever name we want. In this case, as I like to do, call me crazy, but we'll pick something sensible like built resource. And now the only thing we need to do to get this to work is somehow get that ResGen task up above to produce this new item list called built resource. And the way we do that is just under that task tag for ResGen, we create an output item tag, and we say output item type equals built resource. And what that tells MSBuild to do is take whatever ResGen is going to spit out, take that set of files, that set of items, and put them into a new virtual item list called built resource so that we can refer to it later on. The one other thing we need on the output item tag is the task parameter. And the task parameter corresponds to the .NET property of the ResGen class where the outputs are going to come from. So here we're going to say task parameter equals output resources. Beautiful. Let's build this from the command line now and see if we can get those resx to play it into our build process. As you can see, the ResGen task again was kind enough to tell us the exact command line that it's executing under the scenes, so that you can copy-paste that out and execute that step manually if you want, if you were having problems with that particular step. ResGen.exe is being called on the .resx files to compile them into, I shouldn't use the word compile, to build them into .resources files. And then those exact .resources files are being passed into the CSC task so that CSC can build them into the final assembly. So the point I really want you to walk away with here is that in the project file, I didn't have to know anything about the internal implementation of the ResGen task. I didn't have to know that it produces a .resources file. It could have produced whatever, and the way the project file is designed is that you can just take the outputs of one task, whatever they are, and pass them into another task. So a really powerful concept. Okay, now that we've built a new Tetris.exe with resources, let's try running that and see what happens. Great, we pop open Tetris, and it's working. We get the app running as expected. Now, instead of sitting here and waiting for Alex to actually get good at this game, we'll go ahead and close out of that and kick it up one more notch. Now, of course, we wouldn't expect everybody to have to implement their own build process in every project file that you create. We did all of this by hand just to demo the MSBuild file format. But if you were just using a standard build process and didn't need any customizations, we obviously wouldn't expect you to do all of this work. What the project file in fact would look like in that case is instead of having all of these targets and tasks directly in the project file, we would replace them with a single call to import some other file that contains the sort of canonical build process that we want to include. Now, what we're going to type here is import project equals $MSBuild bin path /C#.targets. Now, there's several new concepts here, and I'll go through them one at a time. First, the import. The import is just essentially a macro insertion of this other project file into our current project file. So you can just think of it as just taking that huge chunk of XML, whatever that is in that other file, and pasting it directly into this one. And that way I don't have to have all the targets and tasks in this file. I can have many projects that import the same file and have the same consistent build process. $MSBuild bin path. And $MSBuild bin path is a reserved property that points at the directory where MSBuild is installed. And the reason we need that is because C#.targets ships as part of MSBuild, and that's where it's installed to. So we just need to pick it up from that location. And C#.targets is, again, the file that we ship. It is, in fact, itself an MSBuild project file, and it contains a bunch of targets and tasks. Let's take a quick look at what that file looks like. We're not going to go through the whole thing, but basically it contains a bunch of targets and tasks that replicate the Visual Studio build process as you know it. So when you click Build inside Visual Studio 2002 or 2003, this is what it's actually doing. That black box is no longer a black box. We've exposed it for you. We've declared it for you in terms of targets and tasks. And now you can see exactly what it was doing under the covers. It's no longer a mystery. And this is going to be really important for anybody who wants to customize their build process or really understand what's going on so that they can replicate their build in scenarios that don't have Visual Studio installed. So let's go back to our project file now. And there's one more thing that we need to do in order to make this work. Because our project file now has so many targets, we need to actually tell it what the default targets are. The default targets in this case is just the build target. Before we didn't have to do this because we just had one target, so MSBuild figured out which target to execute. Now we need to be more explicit about it. Now before we reload this into Visual Studio, I want to point out that if you were to go into Visual Studio, Whidbey, and do a File New Project, this is what it would create for you. It would create an MSBuild project file with some properties, with some items, and an import of the appropriate language targets file. So if you were to say File New C# Project in Visual Studio, this is basically what it would create for you. So this goes back to Alex's earlier slide, which is that anybody can author these project files. Visual Studio can author them, a human can author them, some other tool can author them, and they all work the same. So great. So let's reload this into Visual Studio now and see what changes. So as you can see, it's running through a whole lot more targets and tasks. And that is, in fact, because the Visual Studio build process does a lot more than just resgen and compile. As you saw in C#.targets, it's doing whole bunches of things, like it's creating satellite assemblies, it's resolving your COM references, it's running your pre-build and post-build events, it's building your resources, it's compiling, it's doing a lot more. Now our simple Tetris app doesn't really take advantage of all those features, but any application that had items of the appropriate type and the properties set to the correct values would be, for example, maybe creating satellite assemblies and so forth. So there are a lot more MSBuild advanced features of the file format that I would love to discuss with you, and at some future conference, I promise you we'll have more sessions on advanced topics on MSBuild. But today, I want to turn it back over to Alex so that he can show you how one might integrate MSBuild into a larger enterprise-wide scenario and really customize the heck out of it so that you can really do whatever you want to do in your build process. And with that, I give the stage back to Alex. Thank you.
Thanks, Rajeev. So what we've seen thus far is very exciting, and it's still just what you get out of the box in the Whidbey time frame when you get MSBuild. So let's spend the rest of the presentation today looking at what you can do to augment this out-of-the-box experience to really incorporate into it your own individual enterprise needs. So just to recap a little bit, everything we've seen thus far is that MSBuild very clearly defines the Visual Studio build process. That entire build process is expressed in the targets files we just showed. Now that still really just replicates the existing functionality, the existing build process of Visual Studio. Only now it enables you to do it in an environment that does not have Visual Studio installed in it. It allows you to very clearly understand what's going on and augment it. And it really allows you to extend it. Now let's spend the rest of the presentation exactly on that third bullet, and let's extend this out-of-the-box build experience. So let's say that I just got Whidbey out of the box, and I want my build process to also incorporate on every single F5 experience unit testing on my binaries. Assuming the build was successful, I also want to incorporate into that build an actual obfuscation step in my final binaries. Now that I've defined this entire build process, I want to check that into my source code control provider and really seamlessly integrate that entire build process into my enterprise build lab. So how hard could that possibly be? Well, let's find out. Let's actually do it. Step one is going to be for us to augment our build process and include into it the unit test step as well as the obfuscation step. So let's go back to the demo and let's actually change our targets file to incorporate these two steps. So if we take a look back at our C#.targets that we were just looking at, remember this is the file that gets automatically included on every single new project inside of Visual Studio. The target we execute when you click F5 is this build target. Now, I have the build target here, and as you can see, it doesn't really have any tasks within it. The build target only defines a depends on target. Now, Rajeev didn't have a chance to talk about depends on targets, but basically what that concept means is it really allows you to chain together a lot of these different targets. It allows you to set ordering and dependencies within your builds. So what the build target is saying is whenever MSBuild enters this target, I need to execute all of these other targets by their name in their given order. So as you can imagine, if I want to extend or fundamentally change the Visual Studio build process, all I have to do is alter the targets being called inside of this build target. So in our case, we want to add here both a unit test as well as an obfuscate target. Now these are just target names. They could have been anything. But again, we'd like to make them descriptive names. Now rather than actually walk you through the entire set of targets typing it, we're actually just going to go ahead and paste them in. They're really simple targets. They only contain one task each. So as soon as we paste them, let me actually walk you through it. So we have the unit test target, and in it, as you see, we have a very simple task. We have an NUnit task that actually will go out and call the NUnit framework and execute unit tests based on the assemblies that I pass into it. Let me point out that the assemblies I'm feeding into this task are the assemblies that have been emitted by the actual compilation step. Now this is very important because it means that I did not couple my NUnit task with the rest of my build process. It's dynamically picking up whatever the compilation step is actually emitting. Now I didn't write this task myself. I actually just borrowed it from a fellow developer at Microsoft that was using this task in our internal development environment. Now you can imagine that we're already fostering internally within Microsoft, as we're developing all of these projects with MSBuild, quite a vibrant community of folks that are just authoring and posting these tasks. I can't tell you, I can't wait for Whidbey to get nearer RTM for us to ship it so that I can start fostering that community with all of you. I can't wait to see all of you starting to author and post these MSBuild tasks. Now the next target we're calling is an obfuscate target. The task within that target is actually a dotfuscator task. Now again, I didn't author this task. Our partners over at Preemptive.Obfuscator were kind enough to write this task for us and ship it to us so that we could demo it today. Again, this Preemptive.Obfuscator task is going to be taking as its inputs the actual assemblies being emitted by the compilation step. This is it, folks. 8 lines of XML, and I have fundamentally changed the F5 experience inside of Visual Studio. Let's go ahead and save this targets file, and let's go back to our Tetris application. Now, as soon as I compile it, we are going to notice, if we did this right, that both of our steps ran at the end. Drum rolls. And as you would expect, at the end, we did run unit testing. There it is, calling the NUnit task, and actually calling to the NUnit console command line, as well as running the obfuscation step at the end, which is calling to Preemptive's.Obfuscator task. Okay, so I'm going to pause for emphasis here. Do you realize what we were just able to do? We have fundamentally changed the Visual Studio build process with 8 lines of XML. Now, just to prove to you that this is not a sleight of hand on the Tetris application, we're going to create a brand new console application inside of Visual Studio. We're going to say File, New Project. We're going to go to C#, and we're going to create a console application. Normal template, nothing special about it. Once I click OK, we're going to go ahead and create that project. And as you'd expect, as soon as it loads and we build it, I should see my 2 final steps executing right within my Visual Studio build process. And there they are, both obfuscation and unit testing. It was as easy as adding 8 lines of XML code. This is how clear box the entire build process within Visual Studio is becoming in the Whidbey time frame. So let's kick it up a notch and go through the actual final steps of integrating this into our source code control provider as well as our build lab. So until now, most of you actually check in your code into source code control. However, you're checking in both your sources as well as your Visual Studio project files. Now, as we said in the beginning, you're not able to execute those Visual Studio project files in a build lab unless you actually have Visual Studio installed. So a lot of our customers actually in the build lab only operate on the sources. Yes, the projects are checked into source code control, but nobody does anything interesting with it. However, what we're doing in the Whidbey time frame is we are expressing in that project file in its entirety the entire build process of Visual Studio. And now MSBuild, being part of the CLR in Whidbey and part of the operating system in Longhorn, is there for you, which means that in the build lab, you can actually just run MSBuild on these project files, recursively walk through your repository, and you're going to be building your entire product stack in your build lab with 100% parity of what you're doing inside of Visual Studio. Now that's pretty phenomenal. So for the next part of the demo, we actually are going to create a simple, totally demoware. This is not shipping code. I wrote it in 5 hours at best. So it's probably going to crash during the demo. But the idea is that it's a simple daemon written in VB that calls MSBuild on a given schedule. In a normal build lab, you would probably do it either once an hour or once a day. But because this is for demo purposes, mine is actually calling my build process every 5 seconds. We need to do lots of builds. Now this build process is going to be executing a master project file that really orchestrates the entire build lab story and logs all of this stuff into HTML pages. Now let me digress for a moment because we haven't had a chance to talk about the logging infrastructure within MSBuild. MSBuild fires a very rich set of events to any number of register loggers. Loggers are an extensibility part of MSBuild, which we unfortunately didn't have the time to talk about today, but any of you can actually author these loggers. They're as easy to author as the tasks. You implement a very simple interface, you register for the events that you care about, and MSBuild is going to, during the build process, going to be firing these for you. An example of a logger is, for example, the actual Visual Studio logger. So there is a special logger associated with Visual Studio that catches these MSBuild events and logs appropriately to the output window as well as the task list. Now in my build lab, I want to log to HTML so that people can actually come and read a rich website with my full build logs. So I did that. End of digression. Let's go back to the actual master project file. This master project file is really responsible not for the build itself, but really for the build orchestration. As we're going to take a look at it in a little bit, it's going to first sync to my source code control. It's going to sync all of these sources as well as my project files to a local enlistment in my build lab machine. It's then going to recurse through every single one of those project files, and it's going to be building them with MSBuild, so that the build I'm doing in my build lab is exactly the same build as I do inside of Visual Studio. After the build is over, we're going to be doing the normal step of assuming the build failed, we'll send status. So let's actually take a look at this demo really quickly. So let's go back to our demo machine. And we can take first a look at our master project file. So that master project file, as we talked about, really outlines the orchestration of my build lab. I'm not going to walk you through this with much detail, but it's the first target is going to get from source code control. My repository in this case is Visual Source Save. It's going to sync all of these sources to a local enlistment. The next target is the actual build projects. This is the target that's responsible for recursing through my local enlistment and building all of the project files. You'll note that it's just calling a task called MSBuild. This is a task that will in proc call MSBuild with a given set of projects as their inputs. This is the power of tasks. We're not shelling out to an external exe. We are in memory just recursively calling MSBuild. The final target is just a send mail target. It's going to send email with a report of build succeeded or failed. Now remember, all of this is happening with a rich logger. So if we actually go take a look at what the logger is outputting, it's outputting a normal HTML site. I put it on localhost, and if we go ahead and start the daemon, we should start seeing builds happen every 5 seconds. So now this entire website is being built by this very, very simple HTML logger, which all of you are going to get with the sources, by the way. So everything we're showing here, you're getting with the deck at some point when we can figure out how to upload them. So as you can see, I say what build happened, the actual build status, if it succeeded or failed, and I can click on it and see a detailed log of that build. Now, we're orchestrating the build process and we're syncing to source code control, but because there's nothing in my repository right now, we're not doing anything. So let's fix that. Let's go ahead and check in our console application into source code control. So we're checking it into source code control through the normal mechanisms within Visual Studio. As I mentioned, we have a simple Visual Source Save repository set up. It could have been any source code control provider. We'll go ahead and set it up as standard console application root project. It'll go ahead and check all of these projects into source code control for me. And right now that it's done, let's go back to our build lab machine and let's take a look at the builds that it's generating. Now give it just a few seconds because it needs to actually sync these sources from the enlistment and then build them. So if you wait for like a build or two and click on the detail log, we're going to see that he did pick up that console application and he did run all my steps. Now notice that I'm logging here the exact CSC line that I saw both on the console window as well as within Visual Studio. More importantly, note that I'm running my NUnit console as well as my Dofuscator task at the end. I was able to, in one place, one central location, define holistically my entire build process. And I'm able to seamlessly, with very few lines of XML code, replicate all of this in my build lab. Now that's pretty fascinating. Now if we go to our Tetris application, to simulate a little bit more of a product, let's check that into source code control as well. And then let's see the build lab bring it all together and recurse to more than one project. So we'll go ahead and check Tetris into source code control. And we'll give it a few builds for it to pick up. It's still building it. And there's the console application, and right underneath it, there's the Tetris application. It was as easy as that. We've completely integrated Visual Studio and MSBuild into my enterprise needs. I've extended this to have the exact steps I wanted it to have, and I'm able now to have parity between my build lab and within Visual Studio. No longer do I have to maintain a separate set of script files that execute in my build lab from a separate set of project files that I need to use to design my products within Visual Studio. So let's recap what we've seen thus far today. So to summarize, in the Whidbey time frame, with MSBuild, you'll be able to do a few things. The first thing is you'll be able to universally process these MSBuild project files in an environment with or without Visual Studio, and you're guaranteed you'll get parity. Remember, MSBuild is shipping with the CLR in the Whidbey time frame and with the operating system in the Longhorn time frame. The next is the actual file format. As you've seen, we can edit this in Notepad. Very easy to read, very easy to write, very few concepts, and it's fully documented, backed by an XSD, and you can actually get IntelliSense in most XML designers. The final bullet is the actual extensibility. As we have shown, the entire how you build a project is expressed within those targets files. There is this extensibility through managed code of tasks. There's this extensibility through managed code of loggers, so that you really can incorporate this to your very customized enterprise needs. Now you can do all of this without losing any of the integration and readiness that you get from within Visual Studio. You get all of this flexibility. You get to define all of this without having to compromise and lose things such as the very nice debugger we have within Visual Studio, such as the IntelliSense engine, such as all of the red features. Pick your favorite one. They all still work. And now you're able to fundamentally change the build process and incorporate it into all of these features. So let me do a bit of advertising. I know we're running out of time. And then I'll open the floor for a few questions. So if you have questions we don't get to answer here today, please come see us tomorrow at SD Experts. We're going to be hosting a special booth at SD Experts for MSBuild from 6:30 till 9 in Hall G and H. We also have a special news group created, which should have gone live today, which is listed here. It's microsoft.private.whidbey.vs.msbuild. And most importantly, please do fill out your session evaluations by going to myevents.com. We take that feedback very seriously, and we want to incorporate your feedback so that in the next few sessions of MSBuild, we can continue to make them better and better. So with that said, thank you very, very much for your time. I was thrilled to introduce MSBuild to you, and let me open the floor for questions.
Mics. So if you have a question, if you could come to either the mics on this aisle or this aisle, and we'll sort of alternate, and we'll get as many questions as we can in about 15 minutes, 10 to 15 minutes. And then after that, we'll stick around for a few more minutes after that. And as Alex said, there's also the Ask the Experts tomorrow night. So if you have a question, go ahead and come up to the mic.
Okay. Yeah, you keep mentioning the Whidbey time frame and the Longhorn time frame, and I'm not necessarily curious. I'm not trying to lock down dates on that, but the MSBuild functionality will be Whidbey supported and beyond. Will we be able to use MSBuild endpoint to say the CLR 1.1? Or could we use the MSBuild for projects developed with 2003?
So today the plan is that MSBuild really is going to be supporting Whidbey and beyond.
Okay.
You could easily author tasks that are written against the Everett runtime. Say, for example, you write a task that binds against csc.exe from Everett to compile Everett code. But the key feature of MSBuild we were talking about, the full rich integration into Visual Studio, is something that we're not going to be able to do in the Visual Studio 2003.
Okay.
So it's really Whidbey and beyond.
Okay, and the version for Whidbey and Longhorn will be the same? Maybe or maybe not, but supported.
It will definitely be supported. Most likely, it will be the next version of MSBuild.
Yep, thanks.
Okay, I have a question about build layering, or more the descriptor layering. So say that I had at the corporate level a description for how a build should be executed, and then at the application level may be different, and then again at the individual team level underneath that application, maybe some additional. Is there some way that you're planning with MSBuild to do layering?
So the question was, if I may paraphrase, is that how can you sort of have a different build process at the different levels of your enterprise? And I think one way you could do this is by putting conditions on your targets and tasks. So for example, I could put a condition on my target that said, I want to only run this target if some environment variable is set or some property is set.
What I was thinking more of is in the XML, we do a lot of this where you load up the core and then you overlay merged onto that another XML. And ultimately, the total merged target is what you actually run against. So if we had something that comes from corporate, something that comes from you, something that comes from another team, and we're merging that together and then running the build would be much more dynamic, and you would have control of it at each level of infrastructure in the company.
Right. So that's a great question. I think one way to accomplish that is by having multiple import tags in your project.
There you go. That could do it.
Yeah, so you could have an import. You can factor out your .targets files any way you want. So what we showed today is we just imported one .targets file which contained the entire build process. But I could have factored that out into several .targets files and imported each of them, or maybe just some of them, or none of them. And so that would be one way in which you could, I think, accomplish some of the scenarios you're talking about.
A quick, just to augment a little bit, a good way of thinking about our imports is just like you think of styles and style sheets in HTML. You can really cascade them together at each different level and really start augmenting and overriding each different level. So you can think that you'd have, the real baseline targets file sitting on top, and you can start incorporating multiple of these imports, where if you have to overwrite at the, lowest team level some property that was defined up at the, enterprise level, you can easily do that with the import and our property infrastructure.
Okay, let's go over here.
At least superficially, this looks an awful lot like a NAND input file. Would you please comment on the comparison between MSBuild and NAND?
Sure. That's a great question. So let me paraphrase a little bit. The question was the similarity between our file format and the actual NAND file format. Let me start by saying that we love the NAND community. We actually have two of the key contributors for NAND in our alpha program, and we have been interacting with them. And quite frankly, the folks the folks writing based on NAND, they're writing on our platform .NET, so we're very happy and thrilled about them. Now, I think if you take a closer look at MSBuild versus MSBuild and NAND, we tend to take a little bit of a different philosophy approach to it, in the sense that we're looking at MSBuild really as a build platform. We're incorporating into this engine a lot of the infrastructure, whereas NAND is really more of a thin framework, where their philosophy, which is a good philosophy, is to really use extensibility to both tasks and loggers to define all of this. And let me be a little more specific and give you a few examples. The things such as items, where we are defining a project manifest and associating extra behavior with it that we didn't have a chance to show today too much, but things like being able to associate metadata with it, being able to actually have all the tasks emit and consume them, more platform level concepts such as being able to do dependency analysis. And in our case, dependency analysis, which unfortunately we didn't have time to go over today, is a target level concept. It's part of the platform. It's inherent and consistent for everybody, versus being something that you either have to define as a task or that you're pushing down to a given task to do it. Things such as multi-proc support, which again, you can enable just by writing a task that knows how to fan out appropriately. Or you can incorporate and make part of the platform, which then knows how to look at the whole hierarchy and fan things out. So there's a bit of a different approach when we did look at it in the beginning. But to incorporate it and make it hostable by any tool, including Visual Studio, the actual core set of functionality tended to be much thicker than NAND. But From a file format perspective, to get back to your question a little bit, we do have a target-based model, which, it comes all the way back from Make. So that part is very similar.
Okay, over here.
Yeah, so the granddaddy of build frameworks is Make and Make files. And so, when you were talking about these things, there were a few things running through my mind. So for example, Make allows you to invoke commands directly in the Make file. So you have some kind of inline scripting that's possible. Is that possible with MSBuild, or do you always have to write some compiled code and then invoke it through a task? That's one question. The other is, I'm glad you mentioned dependency analysis, because that was something that I was wondering about. Do you do dependency analysis like Make based on timestamps? Do you do diffs? Do you have some other kind of configuration record that's used? And also some features that would be interesting that are available in some newer build frameworks is, for example, built-in support for internet access, retrieving things using URLs and things like that. And also multi-project frameworks that are inherently supported in the build framework.
Okay, let me see if I can remember all those questions. The first one revolved around Make files being able to have inline scripts in them. I'm not quite sure I understand that. A Make file can execute commands, and those commands have to be command line commands. In MSBuild, the analog for that is the task. So an MSBuild project file can execute the tasks. I think part of your question was, can I put the code for the task in line into my project file? Was that the gist of it?
Yes.
Okay.
Yeah, think of those series of commands as a script.
Yeah. So in the Whidbey version of MSBuild, you will not be able to inline the code for the task into the project file, but that is definitely a fantastic feature that we have looked at. Unfortunately, it got cut for Whidbey, but that is a really great feature that definitely will be in some future version of MSBuild, just not in Whidbey. Remind me your second question again.
It was related to dependency analysis.
Right.
How are you doing that? What are you basing that on?
Okay, yeah, that's one of the things I would have loved to demo, and tomorrow evening, I'd be happy to demo it for you. Dependency analysis happens at the target level. And in Whidbey, it is based on timestamps, very similar to Make. And what you would do on the target tag is say inputs equals and then a set of items, and outputs equals and a set of items. And what MSBuild would do on your behalf is check the timestamps of your inputs versus your outputs. And if it determined that all of your inputs were older than all of your outputs, then it would skip all of those tasks for you. So the point of that is that the tasks themselves don't have to worry about their own timestamp checking. The MSBuild target concept does that for you. And so one last question, and then we'll move over here.
Yeah. So built-in internet access, accessed from URNs, URLs, instead of just using file system wildcards.
So if I can take that one really quickly. The way you can think about it is all of those things are part of your project manifest. And that's one of the things that we are looking as part of a platform. We have these items. They don't necessarily have to be files on disk. You can really think more about them as streams so that you can actually model totally in-memory projects. You can model things such as URLs and things like that. Now in view 1, we are looking at items pretty much as files because there's only so much we can do. But again, we have already abstracted and are treating it as very much a concept where tasks are consuming and emitting these items, and they really are just streams. So yes, we absolutely would, over time, support those types of features.
Okay, we unfortunately have only time for one more question, but we'll hang around probably outside this room right after. So if you have more questions, we'd be happy to take them. One more question over here.
Okay, you mentioned that the framework and the XML and all that was going to have a supported schema behind it. Is there any plans for IntelliSense inside the IDE for that schema?
Yes, absolutely. We actually wanted to demo that here today, but we were not able to. One of the things that you are going to be seeing between the bits that you have and the time we ship the beta of Whidbey is that there will be a fairly significant refresh of the file format. And the reason for that significant refresh is so that we can very richly enable the full gamut of XSD features. So we can fully enable rich support for namespaces, for IntelliSense, so that it could really open these project files both within Visual Studio or another rich XML editor, for example, something like XML Spy, and really be able to just open bracket and be able to pick, here's all the list of available tasks, I want to pick CSC, here's the available inputs into CSC, and do very rich both IntelliSense and validation based on schemas.
Okay, so like adding that the XMLNS tag to the file.
That's correct. That will be very much a part of what you're going to see by the time the beta of Whidbey ships.
Okay, thank you.
Okay, thank you very much for coming, everybody. Yeah.
Would it be possible to make your entire directory?
I did save it, yes. Yeah. Right after we were done, I got out and I saved it.
You mean the Tetra?
Sorry?
All of that
Yes.
we're trying to get
Yes,
uploaded
yes.
in a,
Just give
in
me
a
1
zip
second
file
to
to
pack.
the
Yeah, yeah.
one of the websites is ComNet or something like that.
Okay.
We're
Give me 2 seconds.
Yes, we're
We'll be
trying.
right out.
Another question.